Hello everyone, and welcome to the lecture on the check constraint. So a check constraint is a kind of constraint that allows you to specify if a value in a column must meet a specific requirement. We've already seen constraints such as not null or unique used, but check is a really useful constraint to use on your columns. The check constraint uses a Boolean expression of some kind to evaluate the values of a column. If the values of the column pass that Boolean check, so it's going to be some sort of true or false check, then PostgreSQL will insert or update those values. Otherwise, it'll return some sort of error. This is actually really best shown through example. So what we're going to do is go straight to some examples by creating a table and applying those checks. Let's go ahead and go to pgadmin, and I'm going to open up a SQL editor, and we'll go ahead and make a table. All right, so here I am at my SQL editor, and what we're going to do is go ahead and create a table, and then while we're creating the table, we're going to add some constraints to some columns. So let's go ahead and create a table. We'll call it, let's just call it new underscore users table. You can really call it whatever you want. And let's go ahead and add some columns to it. So we always want to add a primary key to a table. Let's go ahead and make a basic one. We'll just call it ID. Have it be a serial data type, meaning it's an incrementing data type, and we'll have it be the primary key of the table. Then what we're going to do is create a first underscore name column. That will be a variable character string, and let's go ahead and limit it to 50 characters. And I need to put a comma here between that column and that column. It's passing a list of columns. Let's go ahead and also put in a birth date as a column. And the birth date is going to be a date type. And what we're going to do is now we're going to put a constraint on it. So the constraint is going to be a check constraint. And then when you're using a check constraint, you have to pass in some sort of Boolean expression in parentheses here on that check. So I can do something like this. I'm going to say that birth underscore date, meaning that column value, needs to be greater than, let's go ahead and say 1900, just the first day, so January 1st. Meaning if we get a new user and they input their birth date, they have to have been born after 1900. So you've probably actually already seen this used in real life when you're registering for a website and they ask you to input the year of your birth date. You usually can't go below 1900, which makes sense because it's extremely unlikely that anyone's still alive if you were born in 1899 or earlier. So let's go ahead and explore how else we could do a check. So imagine we have another column called join date, and that's also going to be a date type column, and then I'm going to have a constraint on that as well. I'm going to check that the join date value is greater than the birth date value. Whoops, let me go ahead and fix that typo. The birth date value. And what that's going to do is it's going to make sure that this new user has joined after they were born, which makes sense. You don't want those dates mixed up. And finally, let's go ahead and add another column just to keep showing you examples of how we could use these these check constraints. Let's go ahead and add a salary value. We'll go ahead and have it be, let's say, an integer type, just some number of their salary. And we're going to check that that value, salary, is going to have to be greater than 0. So they can't make $0 or less. So these are the kind of examples of what we can do with a check statement or a check constraint. So again, we put in the column name, the data type of that column, and then we add constraints to it. And one of the constraints that we're focused on in this lecture is that check constraint. Okay, let's go ahead and run this. And it looks like I have a syntax error. And it's probably because I have an unbalanced set of parentheses, meaning I need to finish off that set of parentheses here. Let me run that again. And it looks like we have our new table set up. Let me go ahead and explore this by saying select from new users. Oops, new users. And here we have ID, first name, birth date, join date, and salary columns. So it looks like those are all good. let's go ahead and try to insert a new row into the into the new users table. And what we're going to see is if we get errors based off our checks. So again, to insert into a table, we say insert into. We have our new users table. And I'm going to insert there. Let's go ahead and insert a first name, a birth date, a join date, and some salary. And then what we're going to do is say values. So now we pass in a list of values we're going to insert. And the values we're going to insert, let's just name this person Joe. Let's say they were born in 1980, whatever, February 2nd, doesn't really matter. And then what we're going to do is go ahead and pass in their join date. Let's say they joined 1990, some other random dates of the year. And what we're going to do is specifically input a salary that doesn't make sense. We'll try to input -10 as a salary and see if that works. Okay, so here we get an error, and it says new row for relation new users violates a check constraint. And it looks like the check constraint is based off what we were trying to input here on the salary check. And something that's really convenient about PostgreSQL is it automatically names this specific constraint, and it does it by, it basically concatenates the table name, new users, with an underscore of the column name, and then it specifies check. So immediately you have a good idea of what check it's failing. Okay, to review this entire topic, let's go ahead and just create one more table, add a simple check constraint to it just so we fully understand. So again, you just say create table. We'll have this be, call it check test, whatever you want. And then what we're going to do is pass in a column name. So we can say something like sales. And this will be, let's go ahead and say an integer, so the number of sales someone did for that month. And then we can just say check, and then some sort of check constraint. So we'll say sales has to be greater than 0. So that's one example of a simple check constraint. And something I wanted to point out is earlier I mentioned that PostgreSQL automatically conveniently named check constraints for you. You can actually name these your own personal name, and you can do that just by adding a keyword constraint, and this allows you to name constraints. So we'll say, we can call this constraint positive sales, and then the name of the constraint afterwards. So if we go ahead and close that off, so I just created a table called check test, has one column in it, sales, integer type, and I used the keyword constraint to name my constraint, that is this check constraint, to make sure sales is greater than 0. So if I go ahead and run that, then what we're going to do is go ahead and insert into that check test, or that that check test table. So I'm going to say insert into check test, and then what we're going to do is insert some values into this table. So let's go ahead and do that. We can go ahead and say insert into the sales column, and then just the values we're going to do. Let's go ahead and try to insert a value that is correct. Make sure that works. So it looks like one row is affected. That looks correct. And let's go ahead and then try to put in a negative sales value column. And notice when we get the error, it'll say violate checks constraint, and now it's the name of the constraint that we chose, positive underscore sales. So that might be a convenient feature for you. If you're checking on later and you get an error, you'd immediately know, based off your description, what kind of constraint error wasn't met. Okay, so let's go ahead and just finish off the lecture there. You can go ahead and check the documentation for check constraints in case you want to figure out how to use it in whatever application you're trying to develop or whatever database you're working with. All right, thanks everyone, and I'll see you at the next lecture.